Good morning, everyone. My name is Srivan Gopal Krishna, and I'm a research assistant at UCL. Today I'll be presenting the PSWARMS project, which is a joint project between University College London and University of Warwick. So the aim of this project is to investigate the existing security processes for IoT-enabled CPS found in utilities, and in particular we're interested in critical national infrastructure. As we know, due to increasing demand and more Industry 4.0 style thinking, our CNI is becoming more and more digitalized, and this leads to a greater attack vector surface. The water sector was selected for us as a development and validation environment for this new security infrastructure we're aiming to build. Working with our industry partners, which are Yorkshire Water and Nexor, the latter which is a cybersecurity company, which specializes in secure information exchange. So working with them, we've come up with an abstracted system infrastructure view, as you can see on the right hand side, and we've narrowed down our scope to the production and distribution assets of this element, along with the IoT, which we hope to secure. The methodology of the project consists of 4 steps. It starts off with domain understanding. So far we've been working on literature reviews, reviewing regulation documents, and we've also done a site tour at Yorkshire Water in the last few weeks, so it's still early days. And we also plan to have a meeting with the Telecommunication Association of Water Industry. The next step, after us understanding the infrastructure of the water sector, is to then look into building security processes and techniques, the first of which is an AI-driven situational awareness tool. This tool would tap into threat intelligence repositories and also internal repositories such as IDS and understand and do some analysis of attack patterns and hopefully feed into the operator database and at the enterprise SCADA level, for example, and this would enable operators to take decisions and respond to attack scenarios. And following this, after building this AI-driven situational awareness tool, we hope to move into a moving target defense mechanism development stage. This would use graph-based modeling to link together different stages of the industrial control system architecture and use evolutionary computing and reinforcement learning to dynamically change the connections between the different layers of the Purview model, which is for this industrial control system. This includes different mechanisms such as shuffling, operating system migration, etc. And finally, although we focus on the water sector for now, we also hope to study its generalizability to other CNI sectors such as the electricity, power grid, etc. And Yorkshire Water has kindly allowed us to use their testbed to enable us to test our techniques and infrastructure. Okay, so this is a bit of a big diagram, so I'll just distill it down. So this is basically a more zoomed in version of the flowchart you saw on the first slide, and here you can see the different connections. So we've worked together with the industry partner Yorkshire Water, and we've sort of distilled down to this high level understanding of how different elements are connected to each other, moving from bottom to up. So we have the field device as an edge device at the bottom, and you have the more IT focused bits on the top. So we've labeled the interconnections between the different elements. We've understood the physical infrastructure as well as the protocols used at these different stages. And through our discussions with not just Yorkshire Water, but also with other water companies, we hope to understand how each company does this differently. And as a result, we'll be able to build quite a generalizable security infrastructure. So some interesting observations you can see beyond this diagram are that firstly, looking at the enterprise SCADA level on the top in green, the recent trend is increasing remote reach out facilities down to the site SCADA level at different water treatment works, and this, as we know, has associated vulnerabilities. The second one is that the protection mechanisms at the lowest field device level is purely based on determinism and physical security, so there's scope to build in more security here. And as we all know, there's limited use of tabletop exercises for training, and I believe that there's some scope to also improve the training of staff to deal with adverse situations. Okay, so this is just a photo of us at Yorkshire Water. We have quite a large team of UCL and University of Warwick, and as I mentioned, our 2 user partners. Yeah, as I mentioned, we've just finalizing the domain understanding stage, and we'll be shortly moving on to the situational awareness piece. Thank you very much, and I'll be there after for any questions.